each and every single one of these formulas up here is simply a shortcut for the original limit definition of the derivative, which is the limit as h goes to 0 of f of x plus h minus f of x all over h. And even though we're learning shortcut formulas so that you don't have to do this, there will be one question on the test where you are still going to do this limit definition just to show you know how to do it. But then the whole rest of the test, you'll be using the shortcuts. So what is the shortcut for the power rule? If you take the derivative, the function x to the n, then what is the derivative of that? Mario? Say that again?
N.
Yeah, n. X.
N minus 1.
Yeah, perfect. So you take the exponent and multiply it out front, and then you subtract 1 from the power. Okay, that's the power rule. How about the product rule? Let's say that I want to take the derivative, g dx, of f times g. Then what is that derivative? James? The product rule, if you multiply f and g together.
F prime times g prime.
F prime, well, just times g. And then? Yeah, that times g prime. And I write it down like this. And folks, let's all practice verbalizing this. The derivative of the first times the second plus the derivative of the second times the first. So really, truly, everybody, let's say it. Repeat after me. The derivative of the first times the second.
The derivative of the first times the second.
Plus the derivative of the second times the first.
Plus the derivative of the second times the first.
Yeah. Yeah, so regardless of how you write those things down, you know, like James, you could have said gf prime plus fg prime. I mean, maybe you just have a preference. That maybe you would rather write down something like fg prime plus gf prime. Is that still the same rule? Yeah, it's still the same rule. So I suppose there's lots of different ways that you can memorize it. So long as you're memorizing that you're going to add them together, and one of them is the derivative, and then the other one is the derivative. You just need to have some way of memorizing that process. I will always verbalize it as the derivative of the first times the second plus the derivative of the second times the first. All right, thank you, James. That's the product rule. What is the quotient rule? So if we take the derivative of f divided by g. What was that one, Elias?
Hody high minus tidy ho.
Yep, Hody high. Well, Hody high minus Heidi ho. Or ho ho. Now, what on earth does that mean? So we would do the, now, Kristen, you weren't here for this. This would be particularly important for you to hear. So the derivative of a quotient, so ho is really referring to the g, the lower function. So we've got g times, and then what does d high refer to? Yeah, the derivative of the top function, so g f prime, and then minus, what does high refer to again?
G.
F. Yeah, f, and then it's being multiplied by d ho, the derivative of the bottom, which is g prime, and then all over g squared. Now, as you look at that, you probably notice that the formula looks fairly similar, right? You've got the derivative of one times the other, and then the derivative of the other times the other, and then you're subtracting instead of adding, and then you're dividing by g squared. So again, that's just a shortcut. We'll do a couple of these today, I think, Kristen, so you'll be able to get to see it. Of course, you can watch the video from last time, too. All right, so that's the quotient rule. And then what about the last rule, the chain rule? So d dx of f of g of x. Boy, that's 3 parentheses. Okay, what's the chain rule, Ashley? Say it again. Yeah, f prime of g of x, leaving the inside alone, and then? G what? Yeah, g prime of x. All right, very good. So how do we verbalize this one? The derivative of the first, derivative of the outside, leave the inside alone, times the derivative of the inside. So again, that's a really good verbiage to have. Okay, so we have all these rules now, right? We've got the original limit definition, we've got our power rule, and then we have our product, quotient, and chain rule. And all of this allows us to virtually take the derivative of any function that we ever see. So let's see here. Let's just see where we are. Today is February 22nd. This is technically a review day, but we still need to finish up 2.5b. but I did give you all a practice test. That's what you picked up here as you walked in. And then when you come back next Tuesday, you'll have a test. Now, let me just share with you what I'm doing for you in terms of prepping for your test. First, this practice test I gave you, you probably noticed that it was pretty thick. And you thought to yourself, geez, why is the practice test so thick? Well, last semester, the students gave me the same feedback. They're like, Mr. G, why is the practice test so long? What the heck? And I thought, well, I just want to give you practice, you know? That's what it's for. So you can practice, and so you're very well prepared for the test. I thought that was a good idea. But they said, no, Mr. G, bad idea. Practice test was 50 questions long. If you'll notice, it's 50 questions long. That's way too much. It's overwhelming. The test isn't going to be this long, right? The test is not going to be this long. The test has only been 20 questions long. So they said, I would have much preferred if you gave me a practice test that was shorter, the same length as the regular test. This is the feedback that last semester students gave me. So I decided to compromise. I still gave you all the practice test questions because I think that these are all good practice test questions, but I'm going to let you legitimately skip all of these. And if you'd like to, you can not do them, and I won't count that against your grade. So what I would do if I were you is maybe just jot those numbers down. You know, you could even jot them down on the back page where the answer key is. And you can go through the whole packet and cross out all those problems if you like. That would be very helpful for me if you actually did literally cross them out, because that way when I'm grading your practice test, I'll see a very clear cross out showing me, oh, that's one of the problems that you didn't have to do.
Are those the ones that we're gonna skip?
These are the ones you can skip.
Yeah, that we could skip. Are they gonna be in the test or no?
Because yeah, I was thinking that like you could be like having that, but one of those actually be on the test.
Do you think that I would do that to you?
I don't know.
That makes me sound pretty devious and mean. That I would like mislead you and be like, oh no, don't do these, and then that's what the test is, was just those problems. That sounds terrible. No, I would not do that to you. I chose these to cross out because there was either another problem just like it already on the practice test, and there was no need for a duplicate, like to do two problems at the same time. Or I crossed it out because I decided either A, it's not going to be on the test, or B, it's going to show up on future tests, so I didn't worry about it. Rosa, did I answer your question? Okay. I'm telling you, you can comfortably skip these problems, and that's okay. If you do all the other problems, you'll still be well prepared for the test. Rosa, thank you for your question. I'm glad that everyone got to that. Anyone else have a question? All right, now there's one other thing I'm going to do for you. Since we won't get to do all of the practice tests today in class, we're going to focus on finishing 2.5B. I will, and I'm already in the process of doing the practice test myself. So I'm going through, and I'm doing the practice test. And then you know what I'm going to do with it? Post it. I'm going to post it on Canvas so you can download it as a PDF. And you can check your work against my work so you can see what I'm expecting to get full credit on the test. So you'll be able to just look and say, oh, okay, this is what Mr. G wants for full credit. I need to make sure my answer looks like this if I have a problem like that. All right? So does that sound fair? In terms of preparing you for the test, you've got a practice test. You know which problems you don't have to do and which ones you do have to do. And I will post this later today so that you can see essentially my answer key. Now, of course, in addition to all that, I hope you email me if you have questions. I'm always available via email, except for right now. Don't email me right now, because you shouldn't be on your phone and I shouldn't either. But otherwise, email me questions, and I'm happy to help. Rosa?
For these equations, are we gonna be able to like write down like a little separate little?
Oh,
are we
boy,
gonna have
Rosa.
to memorize it?
Rosa's asking the big questions today, isn't she? I don't have it with me right here, but I am going to provide you with a reference sheet, and the reference sheet is going to have these formulas. Okay? Obviously, over the course of time of the semester, you'll probably memorize all of these, and you should memorize all of them. But on the test, I don't want you going through the whole test using the wrong formula the wrong way. That's just devastating for you and me. I'd much rather know that you're using the right formula. So there will be a reference sheet with these formulas. Okay. Everybody, you should tell Rosa to keep asking questions. All right. Any other questions about your test next week? The test is over sections 2.1 through 2.5, And all of your Math AS is due on that day. And so is all of the individual practice packets. So how many practice packets are there? 2.1, 2.2, 2.3, 2.4, 2.5A, and 2.5B. So that's 6 little teeny packets that I'm going to collect from you. And then you also will turn in the practice test. The practice test is due for a grade, but I'm only going to grade you on the ones that you didn't have to do. No. I'm only going to grade you on the ones that you did have to do, not the ones you didn't have to do. All right. Any other questions? Does that help everyone feel ready and prepared?
No, I have another one.
Oh, Rosa, there will be chocolate on the day of the test, provided Kristen brings it with her.
Now,
All right, now.
In some of the homework assignments, if we didn't finish some of the homework, like some of the questions, like
Do you mean the paper? Or
on Math AS, are we able to go back to it and finish it? Or
Absolutely, folks. In the syllabus, I said that whatever you don't finish on the day of the due date, you can continue doing after the due date for a 30% deduction.
No? Okay.
So yeah, you can always keep working after the due date.
Okay.
And I hope you do. Yeah, that's a really good plan. You should finish all the homework, even if you don't finish it on time. Finish it at some point, because that gives you the practice you need for the test and final exam and for life. You know, just so you felt like you got it. All right. Well then, I do have a joke to get us started. I do need a little bit of audience participation here. You do know how to do a "why did the chicken cross the road" joke, right? When I say "why did the chicken cross the road," you say "why," right? Or "why did the chicken cross the road?" You can just say "why." And you do know how to do a knock knock joke, right? If I say knock knock, you say "that was pitiful." Almost nobody said it. Okay, so I'm hoping there's some interaction here. I love this joke. So, why did the chicken cross the road?
Why?
To get to your house. Knock, knock.
Who's there?
The chicken! A high school student of mine told that to me, and I thought it was pretty cute and clever. All right, here we go. We ended the last time on number 8, didn't we?
Yeah.
We didn't do number 8? Or did we do number 8?
We did 8.
We did 8.
We're on 9.
Okay, we're on 9. Well, wonderful, because they're both similar. So, in number 9, we would like to take the derivative of 8 square root 5x cubed plus 3x to the 8th. And I should include my f of x. Okay. This is a really good question to review how the derivative formulas work. First of all, this is the primary component we're looking at here, right? The square root of 5x cubed plus 3x to the 8th. That's the thing that we're really interested in. The 8 is just a coefficient. And whenever you take a derivative, what do coefficients do? They just come along for the ride. They just drop right on down to the next line. You don't do anything to them. They just come along for the ride. So we know that the 8 is just going to follow us along down the page. Whereas we want to take the derivative of this thing. And that thing, you have an outside function and an inside function. What's the inside function? 5x cubed and 3x to the 8th. What's the outside function?
8.
Yeah, the big old square root. So right now what we have is 8, which is coming along for the ride, the square root, which is the outside function, and then the 5x cubed plus 3x to the 8th, which is the inside function. So what rule are we going to use? Product, quotient, or chain? This is the chain rule because there's an inside function and an outside function. It's definitely not a product rule because we don't have anything being multiplied. You know, we're not multiplying a square root times the 5x cubed. The square root is the outside function and the 5x cubed is the inside function. It's not a quotient, there's no fraction. So it's definitely the chain rule. Now, can we take the derivative of a square root? Do we know how to do that? We actually don't know how to square root a derivative. I'm sorry, we don't know how to derivative a square root. What do we have to do to the square root? We have to rewrite it as what?
Fraction.
Yeah, something to the 1/2. So now we have our outside function, which is something to the 1/2, and our inside function, which is 5x cubed plus 3x to the 8th. Okay, now we can proceed to do the chain rule. So the chain rule states, again in English, that you take the derivative of the outside function, leaving the inside alone. So the derivative of the outside would become 1/2 times the 8 that was already there. And then the outside function, I just subtract 1 from the 1/2. So I'm going to subtract 2 halves from the 1/2, and that gives me negative 1/2. So I just took the derivative of the outside function, and I'm going to leave the inside alone. Well, what's the second part of the chain rule? Yeah, times the derivative of the inside function. So now what's the derivative of the inside function?
5x.
Bring the 3 down.
5x.
Yeah, 15x squared plus 24x to the 7th. Yeah, so that's 15x squared plus 24x to the 7th. All right, well, we did it. We did the chain rule. Remember, when we do derivatives, the derivative part doesn't take that long. That was pretty fast and easy. That was it. That's the chain rule. But now what do we have to do? Simplify, simplify, simplify. So easily half of 8 is 4. Well, hold on. Let's just think about this. I have this expression to the power of a negative exponent. So what is going to happen to this entire expression right here? It's going to have to push down into the denominator. So let's go ahead and just make a nice big, fraction line. And so now I know I have to drop this component down into the denominator, 5x cubed plus 3x to the 8th, now to the power of positive 1/2, right? Because we dropped it down. Now it's a positive exponent. Half of 8 is 4. Where does the 4 go? Numerator or denominator? Numerator, because it's just a 4. Where does this thing go? Numerator or denominator? Numerator as well. It's just a whole number. So that'd be 15x squared plus 24x to the 7th. All right. I'd say we're just about done, right? What's the last thing we'd have to do to clean this up and put it in final form to give to your audience? We don't leave things with a with a 1/2. Instead, we put it as a square root. So the final answer is you just replace the 1/2 with a square root. And that's your final answer. This is the f prime. That is the derivative. That function will tell you the slope of every point on the graph of f of x. Is there anything else we can do to make that look nice?
If you take out a 3,
You can take out a 3. What else?
3x squared.
You can take out a 3x squared, actually. So actually, to make this look even better, I'll take out a 3x squared and multiply it times the 4. So now that's 12x squared outside of, what, 5 plus 8x to the 5th? All over the square root of 5x cubed plus 3x to the 8th. There, did we do it? Was that correct?
Yes.
I think so, because we took out a 3x squared. If I took out a 3x squared, that gets multiplied by the 4, so that's 12x squared. Then I took out a 3, so it's 5 and 8. I took out an x squared. Okay, yeah. Bit of a lengthy problem, isn't it? Yeah, Anna.
Would you like us to clean it down all the way down to that, or just keep the other one?
I think this is the better final answer.
Okay.
Because in general, we always want to factor. We want to factor. Just like growing up in elementary and junior high school, you always simplify fractions, right? Always simplify fractions. Now, you always factor everything. If you can factor it, factor it. We don't really want to leave it as a polynomial. We want to factor it. Okay, really nice question, folks. Doesn't leave me with a lot of board space unless I just get rid of this. Yeah, why not? Okay, the next one. The next one should feel like a welcome relief. So 3x plus 7 to the negative 1. Which rule are we going to do? Product, quotient, or chain? This will be the chain rule because I see an inside function, which is 3x plus 7, and the outside function, which is all raised to the power of negative 1. So I'm going to write this down as the outside function is being raised to the negative 1. The inside function is 3x plus 7. And that's our function that we're taking the derivative of. So chain rule. Now, Kristen, you didn't get to be here the other day, so I'm going to have you practice this one. The chain rule says you take the derivative of the outside, leaving the inside alone. And then you multiply times the derivative of the inside. So let's take the derivative of the outside first. What's the derivative of the outside function? Yeah, drop down the negative 1. We multiply times the exponent, and then you subtract 1 from here. Yep, so that'd be negative 2. And that's the derivative of the outside. That was just a normal power rule, Kristen. Recall the power rule if you had like x cubed. you would bring the 3 out front and then subtract 1 from the exponent. So that's what we just did. We just did the power rule, bringing the negative 1 out front and then subtracting 1. Okay, we leave the inside alone, but then we multiply by the derivative of the inside. So what's the derivative of 3x plus 7? Yeah, just 3, because the derivative of 3x is 3 and the derivative of 7 is 0. So that would just be 3. Okay, well folks, that was the chain rule. We took the derivative of the outside, leaving the inside alone, we multiplied by the derivative of the inside, and now we just have to clean that up. So again, it's a negative exponent, so what do we know our answer has to be? A big fraction. The negative exponent will drop down to the bottom, so this is now 3x plus 7 to the positive 2, because when you drop an object into the denominator, you change the exponent from negative to positive. All right, where does the negative 1 go? Numerator or denominator? Numerator. Where does the 3 go? Numerator or denominator? Numerator, so that's really just negative 3. Because negative 1 times 3 is negative 3. That's it. That one's done. Sometimes we get so used to doing so much work to clean up an expression that it's surprising when it's just done. There was nothing else to do on this one. Oh, except there was the next question. Don, I finally noticed it. Normally you've been pointing out to me that I keep missing these. So what is f prime of 5? This is our f prime function now. So now we'll go ahead and plug 5 into it. So f prime of 5, that's negative 3 over, see, we can do a lot of this in our head. 3 times 5 is 15. 15 plus 7 is 22. And then 22 squared, whatever that is. So that's negative 3 over, I don't know what 22 squared is.
484.
484?
No. 484.
484. Yeah, okay, yeah, 484. 484. Great. Okay. So that means what's happening on the graph if you were to look at the x value 1, 2, 3, 4, 5? What's happening to our graph at that moment? What does the slope look like?
Our negative 3. And
It's a negative slope. It's going down 3, right 484. So are we talking about a very, very steep slope? Or are we talking about a very shallow? Yes, very shallow. So if I were to come over here and look at wherever that point happens to be, my slope indicator would be a very, very gradual negative slope. That's what the graph would look like right there. It's kind of like we don't actually know what the graph looks like. We're just getting a sneak peek of one little part of the graph. You can't see the rest of it. All you can see is that one part right there. Okay. So let's try that again with the next one, number 11. We've got x squared and 5x and 7 all to the power of 3. What kind of rule will we use there? Will it be product, quotient, or chain?
Okay.
Yeah, chain. Why?
Do we have that outside?
There's an outside function and an inside function. So we've got here f of x equals the outside function, which is what, to the third, and the inside function, which is x squared plus 5x plus 7. Okay. So again, chain rule. Derivative of the outside, leave the inside alone, and then multiply by the derivative of the inside. Elias, you do this one for us?
Yeah. So it's gonna be 3
Yeah, 3
and then 2.
to the power of 2. That's the outside function. And then what do we do to the inside?
X squared plus
So yeah, leave it alone. And then
times the inside prime, so it's gonna be 2 plus 5.
yeah, 2x plus 5. Now, lucky us, the exponent is not negative, so we don't have to drop anything into the denominator. The exponent is a whole number, so it's not a square root. Is there anything else we have to do here? Not really. I mean, just for stylistic purposes, you could put the 3, then the 2x plus 5, then the x squared plus 5x plus 7. But really, that answer was just fine the way it was. There's a tendency in mathematics that we would write it in terms of, putting the smaller one in front because it's a binomial and then the trinomials at the end. But I would have given full credit for that right there. Say that again?
Put the 3 in.
What about the 3?
You gotta plug in the 3.
Oh, right. Okay, so they're asking for f prime of 3. Is that what you're saying?
Yeah.
Okay, so f prime of 3, let's do it. F prime of 3, so we can probably do a lot of this in our head. So 2 times 3 is 6 plus 5 is 11. And then 3 squared is 9 plus 15 is 24 plus 7 is 31. So we have all that to type into our calculator. When it comes down to actually plugging in numbers, folks, you don't have to show me a lot of work for that, because I expect that you're just doing it on your calculator. 3 times 11 times 31 squared. Did anyone else get 31,713?
Yes.
Yeah.
All right, what does that mean? If I look at this graph and I go to the value 1, 2, 3, and wherever that point happens to be, keep in mind I don't really know where that point is. The point could be anywhere along that vertical strip, I have no idea. But what's happening right there? What's our slope?
Really steep.
Really steep. It's going up 31,000, right 1. So my slope indicator would be incredibly steep. It would basically look like a vertical line. And then again, you just kind of imagine that you just have this teeny little window into the graph. You don't know what the rest of the graph is doing, but you know right there, it's incredibly steep. And then, you know, in your mind, you're just guessing about what the rest of the graph looks like. You have no idea what the rest of the graph looks like, but that part of the graph, you have a pretty good idea. Okay, so the next one?
Quotient.
Rosa says quotient. Someone else says chain. This is tough. Is it both? Yes, technically both. We have a chain rule going on because you'd have to do the derivative of the outside first, leave the inside alone, but then you're going to multiply by the derivative of the inside, and that is a quotient rule. So this is a chain quotient rule. You're doing both. So let's try that. This is f of x is that. So again, I'm going to write this out as f of x equals my outside function, which is something to the 5th, and then my inside function, which is x plus 1 over x plus 2. And lucky us, we get to do both. Can you imagine a problem in which you get to do all three? Chain, product, and quotient? Whoa, that would be cool. All we'd have to, we would just have to change this problem a little bit. What if it was something to the 5th, and then the quotient was over x plus 2? But what if the numerator was x plus 3, x minus 7? Then you would get to do the chain rule, the quotient rule, and the product rule all at once. Because you'd have to do the derivative of the outside, leave the inside alone, then take the derivative of the inside, which is a quotient. But in the process of doing the quotient, you'd have to take the derivative of the high, the numerator, and that would be the product rule. Boy, doesn't that sound fun?
No.
That sounds delightful. We should definitely do one of those. There's nothing like it on the test or even in the practice, but that sounds like fun.
Extra credit.
Yeah, exactly. It could be extra credit. You could tattoo it on your face. People would be very impressed. All right, let's do it. Who would like to do this one? How about I've already talked to a few of you today. Karina, what do I do first?
Bring the 5 over,
Take the derivative of the outside function,
and then a 4.
a 4, subtracted 1, and what do I do to the inside?
Do it
Leave it alone. Now what do I do?
the inside.
Yeah, the derivative of the inside. Now this is going to take a little bit of time. You noticed I gave myself, I should probably make my bracket even bigger. I'm giving myself some space because we're about to do the quotient rule, which is the ho d high minus high d ho over the ho ho. And I'll go ahead and write down, I know it's going to be a fraction. So let's try this out. Ho, which is x plus 2, d high, what's the derivative of x plus 1?
1.
It's just 1, because the derivative of 1x is 1, and the derivative of 1 is 0. So the ho d high, the derivative of the top, is just 1. That wasn't bad at all. Minus, and now we do high, so that's x plus 1. D ho, what's the derivative of the bottom?
1.
Just 1 is 1 again, because the derivative of 1x is 1, and the derivative of 2 is 0, so that's also 1. All over ho ho, which is x plus 2 squared. So what do we have? We have 5 times the quotient of x plus 1 over x plus 2, all being raised to the 4th. And then we have what? We know the denominator is easy. That's just x plus 2 squared. What's happening in the numerator? when we distribute the 1 to those, it's just itself. So we have x plus 2 minus x plus 1. So that's x plus 2 minus x plus 1. Now we want to make sure to keep that parentheses on the second binomial so that you're really distributing the minus to both of those. So what does that give us? I suppose we could just do a little scratch work here. X plus 2 minus x minus 1. So the x's cancel and we just have 2 minus 1, which is just 1. So now take a look at what we have. We have the x plus 1 over x plus 2, all of that to the 4th. And now we just have 1 over x plus 2 squared. Right? Did you all get that?
Yeah.
Could we simplify this further? We could actually. What do we notice these two fractions have in common? Yeah, they have the same denominator. And so what we could do is break this first fraction into x plus 1 to the 4th on top and x plus 2 to the 4th on bottom. Since we're raising a fraction to the 4th power, you can raise the numerator and the denominator separately to the power of 4. And now, with that other denominator of x plus 2 squared on the bottom, we can combine the denominators through multiplication. What's our exponent rule for if we do x plus 2 to the 4th times x plus 2 to the squared? How many x plus 2's total are we multiplying together? 6. Yeah. 1, 2, 3, 4, 5, 6 of them are being multiplied together. So our final answer, by the way, where does the 5 go? Numerator or denominator? Numerator. Our final answer is 5x plus 1 to the 4th all over x plus 2 to the 6th. That answer looks really good. Beautiful. Yes, exactly. As Adon said, it is beautiful. It did not ask us to plug in any numbers. All right. All right, now we've got some word problems. Everyone's favorite. Folks, why do you think word problems have a bad rap?
Because there's a lot of numbers.
Because what?
Like there's a lot of numbers like on the sentence, and then like you just don't know what to use.
Yeah, it's hard to get the information, right? It's hard to know what to do. You kind of look at it at first, and it feels a little helpless. Like, well, what am I supposed to do? You would think in a word problem with all those words, they would spend a little time telling you what to do, but they don't do that. They don't take any time telling you what to do. They just tell you the problem. Okay, so let's take a look at number 13. This is next, right? Number 13. Suppose a product's revenue function is given by that. So that's our revenue. Revenue Q is negative 8Q squared plus 700Q. All right. Where RQ is in dollars and Q is units sold. Okay, stop right there. What does that graph look like? First of all, we know we're talking about revenue, so we only need to bother looking in the first quadrant because we're talking about money. And it's an upside down parabola, so it must look something like that. Right? I don't really know exactly what it looks like. It could start on the y-axis. It could start at the origin. It could start over here. Right? That could be. It could be that if you don't sell anything, you have negative revenue. It could be that if you don't sell anything, you have no revenue, but it could be if you don't sell anything, you already have some revenue. What makes the most sense? If you've sold 0 products, how much revenue should you have?
0.
Nothing, right? So which graph is correct? This one. This is the graph that it should look like. Of course, what could we do to check that? We just graph it, right? We can just graph it on our graphing calculator and find out. Okay, so find a numeric value for the marginal revenue at 16 units. So we want to do this both ways. This is technically something new. We haven't done this before. Marginal revenue. Remember, that means the revenue from the 16th unit itself. How much revenue did we get from the 16th unit? So there's 2 ways to do it. Everyone, I'd like you to set up your paper. There's method 1, which is not calculus. And then there's method 2, which is calculus. I'm going to move my graph up. There. Okay, so everyone has, you've got enough space, yeah. So the non-calculus method is the definition of revenue itself. We're saying, I want the revenue from the 16th unit. So what I would do is take the revenue from 16 units and subtract the revenue from the first 15 units. All right, that's what those two expressions mean. This means all revenue from 16 units, and this is all the revenue from 15 units. And so if you subtract those, you're only looking at the revenue from the 16th unit itself. How does that feel as a definition? So that's the definition of the marginal revenue for the 16th unit. Okay, well, we can go ahead and compute that pretty simply on your calculators. Grab your calculator and just type that in. So -8, 16 squared plus 700. I got 9152. And then hit second enter, do the exact same expression, but do 15. I got 8700. And then you subtract the two. And I got $452. Did anyone else get that?
Yeah.
All right. So what that means is that's the revenue from just the 16th item. Not all 16. After all, how much money did we make from all 16 items? 9,152. That's the revenue from all 16. And 8,700 is the revenue from the first 15. So if I look at the difference, that's telling me just the revenue for the 16th item, and that's called marginal revenue. All right, well, that's the non-calculus method. And more importantly, what I'd like you to know is that this is exact. So in other words, it's the real answer. It's the real answer. What does that tell you about what we're about to do?
Fake answer.
It's the fake answer. Well, better word than fake, although I like fake. It's not the real answer. It's not the exact right answer. If it's not exactly right, what is it?
Infinitely close.
Oh, it could be infinitely close. That's a nice way. Or it could just be an approximation. That's what this one is. This one is just going to be an approximation. So it's going to be awfully close to the exact answer. At least it should be. So here's the definition of marginal revenue. All right? Marginal revenue, by definition, in fact, anytime you use the word marginal, all it means is you take the derivative. So if you take the derivative of revenue, that's actually going to tell you the marginal revenue. So what we want to find out is R prime evaluated at 16. So what we'd like to do is find R prime at 16. And what is that going to tell us? It's going to tell us what? Because it's the prime, it's the derivative, it's telling us the slope. It's telling us the slope of revenue at the number 16. So take a look. I'm just going to guess that 16 is right here. Tell me about that slope. It's positive. That means at the moment I'm selling 16 units, my revenue is still going up, and I'm gaining so much money per unit. You know, that's what a slope is, right? Whatever that slope is, let's say, oh, I don't know, let's say it's 400 something. That would be 400 over 1, right? And what does that mean? $400 per 1 unit. 1 unit that you sold. So that's why it's telling us the marginal revenue of the 16th item, because you're looking at the slope, which is telling you you're getting $400 for every 1 unit that you sell. Which unit? The 16th unit. So let's go ahead and take the derivative. What's the derivative of this function? Very simple. It's just the power rule. Negative 16q plus 700. That's it. That's the derivative using the power rule. And now we want to plug in 16, R prime of 16, which is negative 16 times 16 plus 700, which is negative 256 plus 700, which is $444. So let's compare our two answers. First of all, which one is correct? This one. This one is literally giving us the definition of the revenue that we got from the 16th item. So what is this one? It's just an approximation. Well, based on this example, it wasn't very much work to do this. So why would anyone ever bother with an approximation if doing this took very little work? That's a good question. Sometimes this is easy to compute, sometimes it's harder to compute. And so you just have these two options available to you. I will put a question just like this on the test, where I ask you to show me both methods, and I'd like you to set it up just like this. Show me method number 1, show me method number 2, and tell me which one is exact and which one is an approximation. Why is it an approximation? I suppose we don't need this up here anymore. You all have it written down, right? Why is it an approximation? Can we zoom in on what's happening right here on our graph? Look at your slope indicator. There's my slope indicator. If I go 1 unit to the right, how much did my revenue actually go up? If I go 1 unit to the right, like let's say this is 16 and now this is 17, how much did the revenue actually go up to? There. Right? This is the actual point on the parabola. That's where the revenue actually went. But my little slope indicator, because it's just a straight line, it overshot a little bit what its estimation was of how much revenue you'd have 1 unit later, because that's the slope, you know, up so much, right 1. And so you notice there's a difference there. And that's the difference between these two numbers. That one of them was accurate because it was using the parabola that you were given, and the other one was not accurate because it was just a slope indicator, and it kind of veered off and away from the actual parabola. All right? That's that. Those are your two different methods for calculating marginal revenue, or marginal cost, or marginal profit, or marginal anything. That's how you would do it. Let's take a look at another one.
I just have a question.
Yeah.
Maybe you said it, but I might have lost it. But why did you take off the Q from the 700? Took away.
We took the derivative.
Oh, okay.
Yeah, this is the derivative. So this, the 2 times the -8 is -16Q, and then the derivative of 700Q is just 700.
Okay.
Yeah. All right, good question. All right, let's try another one, folks. Number 14. Suppose a product's revenue function is given by that. Find an expression for the marginal revenue, simplify it, and record your result. Be sure to use the proper variable in your answer. Well, that's it. We just have to find the marginal revenue. What's the marginal revenue of that? What's the definition of marginal revenue using calculus? It's just the derivative. So if they say that the revenue is -5Q squared, what, plus 400Q? Everyone go ahead and calculate the derivative. Wendy, what was the derivative?
-10Q plus 100.
Great. So here's a question. When is the marginal revenue equal to 0? All right, this is a hilarious question because what that's saying is at which object that you just sold, like which unit number, was it unit number 200, was it number 230? Which unit did you sell that literally gave you no revenue? Like, can you even imagine? You just sold something and you got no revenue from it. Like, why would you even want to do that? Why would you want to get 0 revenue? I'm sorry, 0 marginal revenue, the revenue from that item. So how would we calculate that? We want to know, when is marginal revenue equal to? 0. So that's our question. Is when is marginal revenue actually going to be equal to 0? Because you would have no incentive at all to sell that item, right? If that particular item, you sell it and you get no revenue from it, why would you bother selling? You would just call it a day and go home. So what would we do? And notice how I boxed this. I might recommend that you box that as well. We want to know, when is the marginal revenue equal to 0? So let's take a look. That's going to be, what do we do? Move the 400 over, and then divide by -10. And so Q is 40? Okay, so that means that on the 40th unit, itself, how much revenue did we get from selling the 40th unit? Nothing. We got no revenue there. Now you might wonder, well, gosh, what does that even mean? I mean, does that mean you didn't take in any revenue? And if that's the case, why did you even sell it? You just gave it away. Well, let's look. The original function was -5x squared plus 400x. So let's look at our, there we go. Well, geez, let me change that window to 0. We'll go all the way up to maybe 5,000. Oh, that's not even far enough. 10,000. How about 20,000? Okay. And we'll only go to the right to maybe 50. Change that to 0. Maybe change that to 100. All right, there we go. It took me a while, but there's our graph. So here's our revenue graph. Okay, so you have to imagine, if you sell 0 units, how much revenue did you get? 0. Now I start selling units. What's happening to my revenue as I start moving to the right? My revenue is going up, my revenue is going up, my revenue is going up. There comes a moment, however, when you've achieved maximum revenue. That's the most revenue you're going to bring in. And how many units was that? 40. That was our moment of marginal revenue being 0. Because right then at that moment, we weren't getting any more revenue from that object, that particular object. And then what happens if we sell more than 40 units? Our revenue actually starts going down. Why on earth would our revenue go down if we sell more units?
Maybe the price changed.
Maybe the price changed, but we typically assume that price is constant. Yeah. It could be that there's an inherent cost associated with selling these additional units. Like, let's say this is just you. You know, it's just you who's manufacturing, what are these things? 40 what? Could they be wooden tables that you make yourself at your house?
With a vanity.
Or what?
The vanity one, like the vanity table.
Yeah, some sort of a table, or, you know, maybe you're a crafty person, you're building something, maybe you make clothing. Maybe you make clothing and you're selling dresses or vests. I mean, who knows? But there comes a point where making these additional items could be cutting into your personal time, your personal life. You got to work all night long. And in order to work all night long, you have to leave all the lights on, use more electricity. All of a sudden, you're spending more money to make these items because you have to do it during the nighttime and it costs more, and therefore your revenue goes down. Okay, so that's just a possible scenario. So in any case, what we're saying is, at the moment of 40 units, the marginal revenue was 0 because the slope was 0. Going from one unit to the next, you really didn't increase your revenue. I want to show that one more time in a picture. Can I get rid of this? Okay, let's say that we're at the top of a parabola. We're all the way at the top. And I want you to imagine, here's one unit, and then here's the next unit. I went from selling, 500 units to 501 units. How much did my parabola go up between those two? Barely, if at all. Maybe even nothing. If I really was at the tippy top of the parabola, could I have moved one unit to the right and my revenue stayed the same? Yeah. And that's what a marginal revenue of 0 represents. So when your marginal revenue is 0, that means you're at the top of the parabola that represents your revenue. Okay, well that's a good question. Let's try 15. Oh goody, this is it. This is our last one. And it's a nice, good, long problem. Isn't that exciting? Are you all excited? You're like, oh, good. It's a long word problem with 5 parts. Parts A, B, C, D, E, and well, just that stuff. So what do we have here? The function P, what do you think it represents? P? Profit. Gives the profit when X units of a certain product are sold. So let's all write it down together. Profit is negative 2.5x squared plus 875x and minus 8,500. What is the shape of this profit curve? It's a what? It's a parabola. How is it facing? Yeah, it's upside down. It's facing down. So let's just go ahead and take a look at it real quick. Always a good idea to see what we're looking at. So negative 2.5 x squared, 25x minus. So here's our profit. There we go. Again, why is it that profit starts by going up, 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 but then at some point profit starts going down? It's not because you're taking in less revenue.
Something else is affecting.
Yeah,
Spending more.
you're spending more money to continue making these products. Like I said, with the example, if you have to work all the way through the night, all of a sudden you're spending more on electricity and other resources just to get the more products made. So there's our profit curve. So keep that in the back of our mind as we go ahead and start these problems. In fact, maybe I'll leave both of those up there so we can look at both simultaneously. So first question, find the profit when 90 units are sold. You just plug it in. So part A, profit at 90. So you just go ahead and plug it into your calculator. That will tell you the profit when 90 units are sold. So what do we get? Negative 2.5, 90 squared, plus 875, 90, minus 8,500. What did you get? Yeah, 50,000. Now again, folks, I know I focus on showing all of your work, but this would be sufficient for me. Because there's no calculations to do here by hand. You just plug it into your calculator and write down the answer. Okay, so that's the profit from selling 90 items. How about part B? What's the average profit? So how do we find the average profit per item? Because that was the profit from all 90. So on average, how much profit did we make for each item? Yep. The average profit is 50,000 divided by 90. And that will tell you how much profit you're making per item. So divide by 90, and what do we get? 555 and 56 cents. So that's your average profit. Boy, I'd like to make these items, whatever they are, especially if I can make them at home. All right. What's the rate that profit is changing when 90 units are sold? Now this problem is worded a little differently. We haven't used this wording, but they're saying what's the rate? So first of all, what is rate always talking about? Slope. What is the slope when profit is of profit? What is the slope of profit when 90 units are sold? So what are we trying to find? Yeah, what's the slope at 90? And how do we write that down? It's P prime, that's the slope, at 90. That's what they're asking for. What is the rate that profit is changing? That means we want the derivative. When 90 units are sold, and that means you plug in 90. Well, I suppose first we have to calculate the derivative before we go plugging in 90. So what's the derivative? Yeah, negative 5x plus 875. So now we can calculate the derivative if we plug in 90. So negative 5 times 90. 5 times 90 plus 875. That's $425. What does that mean? It's always a good idea, whenever you calculate a derivative, to go ahead and ask yourself, what does it mean? So does that mean that I made $425 profit from that item? Is that what that means?
Does that mean that the 90th item gave me $425 in profit? Can we calculate how much the 90th item gave us in profit?
Yeah.
How do we do that the non-calculus way?
Wouldn't we just do P of 90 minus P of 89? Well, we can do that real quick.
So negative 2.5 90 squared plus 875 90 minus 8,500.
So my profit from 90, oh, well, we already knew that. It was 50,000.
And then the profit of 89 units is
49572.
and if I subtract those two numbers,
Yes, I got a difference of 427.5.
so what was the 425 telling us?
What means the approximate?
The profit I got from that item, the 90th item. Right there, that 90th item, the profit was 425. How much actual profit did you get?
427.
427.5.
So
Which
the
answer?
425 is like the approximate.
That's an approximation.
Whereas this one is exact.
So yes, the derivative, while that does represent a slope, it is a slope. It's literally, that's marginal profit. It's telling you the profit for the 90th item. For that item, you made $425 in profit.
Okay, so that was the rate that profit was changing when exactly 9 units are sold. So as a rate, that would be 425 over 1. And what does that mean? You made $425 in profit for every 1 unit that was sold. And the 1 unit that was sold was the 90th unit. And so you made $425 in profit. The rate that profit changes on average when the number of units sold rises from 90 to 180. How on earth are we going to find this out? Do we even know what this question means? The rate that profit changes on average when the number of units sold went from 90 to 180. First of all, look at our graph. Where's 90 units? Right up there. Is that 90? Everyone make a mental note. Well, I'll keep my finger pointing at it. And where's 180 units? Right there. Ooh, yeah, it is really close to the middle. It could be a little bit right of middle, but it's pretty much there. So where were we? Here and here. There's our 2 points that we're asking about. What was the average? They're saying, find the rate that profit changes on average when the number of units sold rises from 90 to 180. What are they asking us to compute? A what? What's in the middle? I suppose they want to know the average rate of change from here to here. So what are we calculating? Maybe someone already said it and I didn't hear it.
The slope?
The slope, yeah, what kind of slope? Tangent slope or secant slope? This is secant slope. Because we're just going on average. On average, we're going from here to here. Can you see the dotted line? I can't draw it. But there'd be a dotted line right there going the secant slope between those 2 points. So that's what we want to find out here, folks. Let's go ahead and see how to write this down. It says the rate that profit changes on average when it goes from 90 to 180. Everyone go ahead and draw a little graph. Just a little graph, a little fella. And put in 90, which we know is over here somewhere. And then put in 180, which we know is towards the top. And make yourself a little dot, 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 so that we really are visualizing and understanding what we're doing. So what are those 2 coordinates? We want to find a slope. We're going to use the slope formula, y2 minus y1, x2 minus x1. So we need those 2 coordinates. What are they? And let's remember how to write down the general coordinate. What's the coordinate for this point? 90, comma. Well, now that's true. I already know that that's 50,000. But let's write it down in the general way first of P of 90. 90, comma, P of 90. I'd like us to all feel really comfortable always just doing that. But if you didn't already calculate what it was, you know the general coordinate would be
90 comma P of 90. What's the next coordinate?
180 comma P of 180. And therefore, if we wanted to calculate this slope, what would it be? P of 180 minus P of 90 all over 180 minus 90.
It's helpful to just be able to write it down like that. And the more we do it, the more comfortable we'll feel doing it. So much so that in the future, you might even just find yourself writing that down directly. You're like, oh, I need to find the slope between 90 and 180. You know that you just write it down like this. The function at 180 minus the function at minus 90. And so now I know my denominator is simply 90. And now you can use your calculator to calculate the rest. You don't even really have to show me the work for that. You just need to use your calculator. There we go. So it's going to be 180. So if it's already in your calculator, you can just go back to that screen where you typed it in and edit it. I got 68,000. So yeah, I got 68,000 minus the 50,000 that we already had, which is 18,000 over 90, which is 200. Does that answer make sense? What are we saying? What does the 200 mean? It is the average slope. And what is this formula even telling us? Profit. So we're saying that on average, how much profit are we making on every single item? 200. Now, does that make sense? We just calculated a second ago that we were making $425 from that item. Now this is saying on average we're only making $200. What happened to all of our money?
Resources.
What's that?
Resources.
Resources? Well, yeah, that's part of it.
Well, I had to increase the price because of the products you're getting.
We didn't increase the price. Everybody take a look here at our graph. Remember, profit per item, marginal profit, is the slope. What was the slope right here?
420.
425 over 1. Now, it's pretty steep, right? It's pretty steep. What's the profit at the top where we just were? What's the profit right here? 0. Right? You're making no additional profit by selling that item. The marginal profit selling the item at the top was nothing. So if you were to take the average profit, over here you're making $425 per item. Up here you're making no dollars per item. What's the average, or the middle, of 0 and 425? Just roughly speaking, what's the average of 0 and 400? 200. Okay, so that makes sense then. That makes sense that the average profit between these two was not a slope that was that steep and not a slope that was that shallow, but you'll notice that the average secant slope was a middle ground. It wasn't as steep as the first one, it wasn't as flat as the last one, but that new slope is the average profit. Okay?
How you make up your mind.
Yeah, that is how you make up your mind. Because if you're a business owner, are you motivated to sell that item, the 180th item? No, you have no motivation at all, unless it's a relative, right? You're like, yeah, Bob, Uncle Bob, I'll make one more for you, even though I'm not making any money off of it, right? But would you do it for someone off the street? If they walked up to you and they're like, hey, I hear you're selling these fancy dresses you make at home. You're like, yeah, no, I'm not doing that anymore. Because why would you? You're not going to make any profit off of it. You'd have no reason to. So how many items do you really want to sell? Somewhere over here, right? Because this is when you're making the most profit. But now that's just the most profit, right? Just because the first item, you're making a ton of profit, aren't you? The first item, you made a ton of profit. But that doesn't mean that's enough money to live off for the year. Right? Just because like you sell one dress and you're like, I made $1,000 in profit off that dress. And now I can live until Tuesday. Right? Because you need more than 1,000. So you're going to have to choose somewhere between here, right? You want to make as much profit as possible, but you still need to make an annual living. So you might end up, working your way all the way up to the top of the parabola. But would you ever want to go past it? No, you're getting negative profit. You're actually losing money for every extra item that you make. All right, well, folks, that was fun. Bam! That's it for 2.5B. So, folks, that means we'll take a break, and then when we come back, we can just spend a little time looking at the practice test and taking any questions that you want to ask. So let's all take a break. It is 12:07. We will start back up again at 12:17. Elias.
Yeah.
Am I pronouncing your name right?
Yeah.
Okay, good. I was worried that I was saying it wrong. Elias, is that short for anything? Elias is the full name.
Yeah.
And is that named after anyone in particular in your family?
That's why I actually chose it.
Oh, that it
Like,
wasn't the family name.
It's just like no one has it.
Elias is a really good name. My wife is pregnant right now, and we have no idea if it's a girl or a boy.
How far is she?
She's due in July. So what does that mean? She's at least halfway there, probably?
Yeah.
Yeah, she's just finally kind of showing a little bit. But I remember on our first baby, we were talking about boy names, and I really liked Elliot. But Elias, that's really cool, too. Anyway, no pressure. I'm just considering your name for my baby. You know. It is a nice name.
It's good to be a teacher because you learn so many names, so that when you
Mhm.
have like a,
Yeah, absolutely.
no, he's gonna be saying
Actually, Elias, that would be an awesome name because our daughter's name is Eloisa.
Eloisa.
Eloisa. I think that's a Spanish origin name.
Eloisa.
Yeah, it's not Eloisa. Eloisa. But-
Eloisa.
What's that?
It's Eloisa.
Uh-huh.
Eloisa.
Well, that's the thing. I know that it would be pronounced Eloisa in, say, Spain, but my wife's grandmother, her name was Eloisa, and they pronounced it Eloisa. So could you just imagine if our daughter was Eloisa and our son was Elias? Oh, man. I could handle it, but I'm sure relatives would be like, what were you thinking?
Mr. G.
Yeah.
So we don't do part E? Any question?
Oh, we didn't do it? Oh, geez, we have to do part E. Silly me. I do want to do part E. The number of units sold when profit stops increasing and starts decreasing. Oh, okay, that'll be easy.
So this is extra credit. An extra credit card, and then she wants it to. Don't take me 2 seconds. She does.
It sounds like
That's what
2:30.
That's just good.
Usually I put it in. I think I put it in.
Do you guys do multiple streets?
Yeah.
Um,
You don't.
yeah, we do. Also, too.
Somewhere in there. You know, I don't like it. I don't know if I'm like between two answers. And the only difference is like the word.
Everything we can like that's one.
You have like the same thing, just like maybe once it's
Mhm.
right, it's either and then when you break out. And I don't know why. I was thinking to second guess because since I had a crit at the last minute, I'm like, I'm going to and then I really like catching it. And then when I look at it, I'm just like, I haven't.
I do that too.
Because I was 10, 4, which is like the stuff that I had. It didn't, so next time I just not really.
I just look from a beat to a. But we should get in. I just make sure everything's.
Usually,
Because I know I'm just gonna mess it up if I keep going.
if they give it to think is that
Yeah,
it?
you really keep going.
Or you know, I don't know what happens with you. I'm posing the questions that like you're working on it and then you're like halfway. Whatever answer you have there already, not just on the answers or on most people, but there's still a second part to it.
No,
I don't know. Because for example, right now you were doing one that everybody else is calling. Once you're working on it, within your work, one of the numbers you get already matches with one of it. That's why building up and like circle that. But I guess you had to keep going and go different answers
Yeah.
and numbers like that. Like because it makes you stop and be like, oh, that one's really good.
yeah, I haven't done it, but we never did it.
She told us that we are something and that's not that she didn't have it. And when we got there, she was there. So she's like, no, I'm
Yeah.
thank you.
She loved that too. Giving it back to us, because she knew we had done something. Because it was like that profile. And then at the end, I was thinking, just take it. I was like, it's not gonna change. I'm not gonna like magically remember.
And then
But she was trying to help us.
even for that, that's why she made like that because she usually doesn't do that to us. She just like grabs it.
Well, that was for the final, for the regular. We just
Well, I don't know exactly because it's because last time we had a fun she didn't do it.
I think it's because of. I'm not going to put it like we're not that. 8, 10. It's not that big. Also, center class.
There's like 10 of us from that. So 12. Business, right?
You? County?
I have to get this right.
This was what the teacher had to send to us. Oh, I still have like 2 after. So county? I think the county would be more.
Because they told me this, I guess it's bad. I need to transfer it to.
What for that if you say?
Was that? Yeah. It was. Well, I still have some.
Hey, I know, we're done. All right. Part E, folks, I forgot part E. Let's go back and look at part E. It said the number of units sold when profit stops increasing and starts decreasing. So what is that on our graph? When the profit stops increasing and starts decreasing, what are we talking about? What point on our graph? The maximum. We want to know the maximum. And what do we know for sure about the maximum? What's the slope at the maximum? 0. That's really handy. That tells us how to solve this problem. If we want to find the number of units sold when the profit stops increasing and starts decreasing, we're looking for the top of the graph. And the top of the graph has the property that the slope is 0. That's very handy. We're going to use this over and over in this class. If you want to find the maximum, you take the derivative and set it equal to 0. So let's do part E. What was the derivative of our function? B prime was negative 5x plus 875. And I'd like to know, when is that equal to 0? And let's really think about this one so we understand what we're saying. We want to find the number of units sold when the profit stops increasing and starts decreasing. That means we want to find this number right down here. How many quantity, I guess we're doing X. How many products would we have to sell so that we're at the tippy top of the graph? And the tippy top of the graph has the property that slope is 0. And that's why I'm going to take my derivative function and set it equal to 0 and then solve for X. So I'm going to go ahead and solve for X. Negative 5x equals negative 875. And then divide off the negative 5. And that's X equals
175.
What is it? 175. 175. Okay, now back to the graph. That means at 175 items, the profit is at a maximum. So 175 is the number of products that must be sold when the profit stops increasing and starts decreasing. And what that really tells us is maximum profit. So again, do you have any motivation to continue selling items after maximum profit? Maybe, maybe not. Let's say that you've been making your dresses or hats or whatever you make all year long, and you just reached your 175th sale, and that was the maximum profit. I don't even know what the maximum profit was. We would have to plug 175 into this function and find out. But that would be the maximum profit that we would get. Let's go ahead and find out what that is. Our maximum profit, because remember, that's keeping track of all the profit we've made so far. So that would be what? All the profit we've made so far from selling 175 items. 875. Oops. There we go. So all the profit we've made so far, did anyone else get 68,000?
Yes.
Okay. That's the profit we've made. Right? So if I now proceed to sell more, let's say I go sell my 176th item, now the amount of profit I will have is going to be less. So now my profit for the year would only be, say, 60,000 on the dot. So really, would we be motivated to do that? No, now we're taking less profit. Less profit, right? That's the profit from the company. If this is your company and one of the line items of your costs is paying you a salary, then maybe you don't care if the amount of profit goes down because you're still getting paid your salary. Okay. So folks, that was the answer key. We're now going to take a look at the test review. Now the practice test, I would say that there's a few problems on there that I would be more excited to go over with you because we've already kind of done a lot of these other problems together. Whereas what I would really like to do is look at some of the word problems. So for instance, everybody skip all the way to number 19. 19, 20, 21. Sorry, 19, 20, and 22. Yeah, since we have about half an hour together, I would like to continue focusing on the word problems from the practice test. Because I think you can go back and do more of the computational stuff on your own. Is that okay? We'll focus on the word problems. But right now, if while we're doing this, if you want to flip through and identify any problems that you're like, whoa, how do you do that one? Then maybe we could reserve the last few minutes at the end of class to take any questions. But for now, let's go ahead and take a look at these word problems, because word problems are the exciting ones. I want you all to feel good and confident about reading a word problem and answering it. So everyone run number 19. Number 19. The total cost is given by that function, 5.1q plus 44,000. What do we call the 44,000? Fixed cost. What do you call the 5.1q? Variable cost. Okay, so those are our costs. What does it cost to produce 1,500 units? What do you do?
Plug it in.
You just plug it in. Okay, that's easy enough. We'll move on to the next question. What is the cost of the 1,501st item? How do you find the cost of the 1,501st item? I'm not going to do part A with you, but I will do part B with you. How do I find the cost of the 1,501st item?
Don't you?
Plug them both in.
Yeah, you plug in both and you subtract. You find the cost of all 1,501 items, and then you subtract the cost of the first 1,500 items. And that's marginal cost. That's the cost just of the 1,501st item. I'm not going to calculate it. I think if we just set the problems up and talk about them, that would be the best use of time so we can get through more problems on the practice test. So, so in that case, I guess I could go ahead and show you. The first one would simply be C of 1,500. Right? So that's the setup for that number 19. I feel like we just did one of those. How about number 20? Suppose your demand function is given by that. So let's review. What does a demand function tell you again? This is D of Q.
Oh, the price.
Yeah, it's the price. Remember, that's the weird one. It's called demand function, but it's actually telling you the price you can set for that item and sell your whole inventory. Remember, that's what it means. The demand function is going to tell you what price you can charge, and society will buy you out. You won't have any leftover stock. You won't run out. Everybody will be very happy. So what does it ask? Part A, if 12,000 units are to be sold, what price should be charged? So what do we do? They're asking for the price. Yeah, just plug it in. Do we plug in 12,000?
12.
Just 12, because Q is in thousands. So we would calculate D of 12. So again, I'm just kind of helping you set up the problems. I'm just writing down D of 12, and now later on, you can go in and plug those in and finish it.
So
Okay,
I think that was my issue with mat213. I would just put like the, how like when I asked you, I would just put
Oh yeah, whether to put in 12 or 12,000.
Yeah.
Yeah, so be careful with that. Okay, if a price of 232 is set for the item, how many units can you sell? So now, where do we put the 232? What's that? Yeah, it's equal to 232. So now we're saying, set this formula, negative q squared minus 2q plus 555, equal to 232. Right, that's what we're saying. We're saying, what if this price equals 232? So then what? How do we solve for q? I'll do this whole one with you. Did we do what, Anna? Yeah, move everything to the left and then factor it. So I'm going to bring that to the left. Now we have negative q squared minus 2q plus 168. Someone should really check my math on that. I think I just did that wrong.
It's 323.
Oh, wait, what is it?
323.
Oh, 323, my goodness. How could I have been so far off? All right. Well, folks, I don't know about you, but did I write that formula down here? Yeah, and it was 232, okay. I don't like to have my first term negative, so I'm gonna multiply through the whole equation by -1 so that I have q squared plus 2q minus 323. Sure. Okay, well, does that even factor? I don't think that even factors. So what would we do instead?
Quadratic.
Yeah, the quadratic formula. So q is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, other than writing that down at least once, you can do all of that in your calculator. So 4 plus 4 times 323 is 1296. So I have -2 plus or minus the square root of 1296. Oh my gosh, it does factor. Folks, how exciting, that would have factored. I mean, I know that we're all just really excited about that. Don't you want to go back now and find out how it factored? Now, why am I even saying it factored? How do I know that?
It's even.
Yeah, it came out to a whole number. So that would be -2 minus 36, all divided by 2, which is -19. Or -2 plus 36, all divided by 2, which is 17. Which answer is correct? Yeah, 17. So the number of units is 17. By the way, how would it have factored? Yeah, q plus 18 and q minus 17 would have given us the answer. But I wasn't even optimistic about 323. I thought, geez, what would go to 323? We should have tried it. All right, so that's part B. If the price of 232 is set for the item, how many units can you expect to sell? 17. 17? The answer is not 17. 17,000. Yeah, 17,000 products is what you'll sell. Okay, part C. At what value of Q does it cross the Q axis? What does that mean? Our original function was an upside down parabola, right? And so what are we wondering about?
0.
Yeah, where does it hit 0? And so what formula would we solve? We want our function not to equal 232. We want our function to equal 0. Well, what does that even mean? The price is 0? What does that mean that the price is 0? What happens if the price is 0? What are we doing with our items? We're just giving it away for free, standing on the street corner. Here you go. So again, I would change all my signs. Q squared plus 2q minus 55, 555. This one I do not believe factors. So this one we really do need to do the quadratic formula, -2 plus or minus the square root of 2 squared minus 4 times a times c. I don't think this one will turn out. So you just have to use your calculator. 4 plus 4 times 555. Oops. 2, 2, 4, all over 2. Which is -2 plus or minus 47.159. I guess we should talk about decimals. How many decimals should I keep?
3.
Now, probably at least a few. I might even do 4. And now, -2 minus 47. Do I need to worry about the negative solution? Do I even need to bother typing the negative solution in? No, that doesn't make any sense. So I'm just going to do the positive solution. And then divide by 2. I got 22.4
579. And what did that represent? 22.5 what? Is it just 22 units? Are these just Lamborghinis I'm selling? 22 of them? What were my units again? 22. Q is in
1,000.
Q is in thousands. That's not 22.5, that's 22,000. And so that's a really good thing we kept so many decimals, right? Because that's literally 22,000. I just go ahead and put a comma right there. And that is 22,579 units that I sold. So it's a good thing we kept at least 3 decimals, because that's giving us an accurate answer as to how many actual units we're selling. Okay.
So this answer was for B?
This was the answer for B. Yeah. No, this was the answer for C.
Yeah.
At what value does it cross the Q axis? So if you sold 22,579 items, the demand function would compute a cost of $0, which, makes no sense. You just wouldn't sell that many. All right. Here's another good one. I don't think we've done a problem like this. So I'm really glad we had the time to take a look at it together. This problem that we're about to do, we're going to see over and over and over again in this class. In fact, what's the name of this class? Business calculus? Isn't that the name of the class? Anyone? Is it called business calculus? Do any of us know the name of the class we're in?
Brief.
Brief calculus. Okay, that's true. It's brief calculus. But the subtitle there is business calculus. What we're really looking at is business applications. Okay, so here's a great problem. This is a great problem. I would take it home and do it over and over again to make sure you feel really comfortable with it. Let the demand function for a product be given by this function. So what is that function telling you again? The demand function is telling you price. Okay? Yeah, the price that you should charge to sell out of your inventory. So there's our demand function. Q is the quantity of items in demand, and DQ is the price per item in dollars. They can be charged when Q units are sold. Suppose fixed costs of production are $4,000 and variable costs are $8. Let's just take that right there. What's our cost function? Cost is what? 4,000 and the variable cost is $8. What formula would I write down? Yeah, 8Q plus 4,000 or 4,000 plus 8Q. Either way, that would be our cost function, right? Now let's just glance at all these questions real quick. If 26 items are produced and then sold, so that's what we're wondering. What will happen to our business if we make 26 units and sell all of them? Yeah, we'll do a lot of plugging in. So first they want to know what's the total revenue, then they want to know what's the total cost, and then they want to know what's the total profit. Okay, so this is good. This is a nice snapshot. Are we doing any calculus at all? We're actually not. There's no calculus here. It's just finding the total revenue, the total cost, and the total profit. So let's go ahead and start from the beginning. Part A. What is the revenue? Well, first of all, what is the formula for revenue? You find revenue by
Profit.
not profit.
No.
Profit is defined from revenue and cost. Revenue is just one simple formula. I mean, what is revenue after all? That's the money that goes into the cash register, right? There's no derivative. That's marginal revenue.
Is that price and quantity?
Price times quantity. That's it. Revenue is price times quantity. That should make sense again if you have an ice cream shop and you're selling 2 scoop ice cream cones and that's all you're selling. Then you have how many ice creams you sold and the price of what you charged, and that's your total revenue. So revenue is always price times quantity. Well, in this particular case, let's go and say R of Q. What's our price? What is our price?
DQ. So
Yeah,
it's
D of Q. So our price is actually D of Q, the function, being multiplied by Q. I'm going to write this out very formal, right? Maybe let's all write it down. Our revenue for Q units is the price function, the demand function, times Q units. That's price times quantity. Okay, now let's actually plug that in. Our revenue is negative 1.85 Q plus 290 times Q. And then you distribute the Q in and get your final answer. So my revenue formula is negative 1.85 Q squared plus 290 Q. Now we can actually answer the question. What's the total revenue from selling 26 items? What do we do?
why is just a negative 1.5 Q squared?
I distributed by Q.
Oh, okay, yeah.
So now what do we do?
Plug in 26.
Yeah, just plug it in. Negative 1.85 is 26 squared plus 290 is 26. Did anyone else get 6,289? Great. And 40 cents. Now you'll notice, what work would I like to see on your test? I'd like to see how you derived the formula. This is the formula for revenue right here. This was setting it up by definition, price times quantity. This was saying that you know that the price is the demand function. This is plugging in the demand function, and then that's actually distributing in the Q. I suppose you don't have to show all those steps, but somehow you need to show me how you got to here. But then when you actually plug in 26, you don't have to show me any work at all. You're doing that on your calculator. You can just tell me R of 26 is equals to 6289. Okay, so that's part A. How about part B? What is the total cost for 26 items? Do we already have our cost function? Yeah, so just plug it in. So now I'll find cost for 26 items, which is 8 times 26 plus 4,000. And again, you don't have to show any work. You just write down what you got from your calculator. Did anyone else get 4208? No? Okay. All right, and what's the last question? The total profits for 26 items. Well, what's our profit formula? Generally speaking, the concept itself, what is profit equal to? Just the concept in English. Profit is revenue minus cost. Okay, so then our profit for Q items is simply R of Q minus C of Q. That's what it would look like formally. And because we're subtracting two functions, you want to be really careful about this subtraction, that you put your cost in parentheses so that you distribute the minus to all the terms inside. So what is our profit then? The revenue was negative 1.85 Q squared plus 290 Q. And then I'm going to subtract my cost, which was 8Q plus 4,000. It's really important you have those parentheses, so you distribute your minus. So minus 8Q minus 4,000. So 290Q minus 8Q is 282Q, and then minus 4,000. Is that the correct profit function? Did anyone else get that? I think that's right. So that's the formula for a profit. Now what do we want to find? Yeah, the profit for 26 items. And again, at that point, you don't have to show me any work. You just type it into your calculator. So negative 1.85 26 squared plus 282 26 minus 4,000. Now, right now, some of you might have your spidey senses going off. Mr. G, why did we just have to do all that? Well, I do want you to do this because that's your profit function. I want to see your profit function. Did we have to type anything into our calculator? How could we have gotten this number?
From the previous.
Yeah, from the previous two numbers. Didn't we already know what our profit was? Revenue minus cost. Let's see, 6289.4 minus 4208. Aha, it's the same value. So.
I did that last time. How would you know?
Oh yeah. So again, the spidey senses. You might be like, why are we doing all this? Well, because you might still want to know your profit formula. Just because you could have subtracted those two to get directly to this answer, knowing the profit formula is helpful because now you could take the derivative of it and talk about marginal profit. Right? So there was a value to getting this formula. And so I guess on the test, I want you all to know that on a problem like this, I want not just to see the revenue, cost, and profit of 26 items. I want to see the formulas that you created to do so, okay? So I'm telling you that right now as a group, that whenever we do problems like this, I want to see the formula and then go ahead and tell me what the answer is. But I want to see the formula. Okay. All right, number 23 we've crossed out. Number 24, that's just computational. These are computational. Ooh, 33. Let's do 33. This one looks fun. We haven't done one quite like 33. We've talked about it. Very exciting problem. What does it say? The graph of f of x has two horizontal tangents. What does that mean? The graph of f of x has two horizontal tangents. Well, first of all, everybody look at this graph. How many horizontal tangents does this graph have? How many times does my tangent slope indicator become horizontal? Boop. Just once. There's one boop, horizontal tangent. This is not horizontal. This is not horizontal. That is horizontal. So what does a horizontal tangent represent? Either a maximum or a minimum. All right, so every horizontal tangent represents a maximum or a minimum. And they're telling us that this graph has what? Two horizontal tangents. Well, what does that mean? Does that mean it has two maximums? But now I have three, so that can't be the case. So what must it have? Something like that. So I've got one horizontal tangent here and one horizontal tangent here. So that must be what the graph looks like. How do we know for sure? Type it in. You all have a graphing calculator. If you wanted to during the test, you could type in the formula. Oops. 2x cubed plus 12x squared. This will be the last problem we do together, folks. Minus 126x. Not forever. That sounds, scary. I just mean today. Okay. So here's my graph. Ooh, you really got to zoom in. You see the little wiggles down there? There.
Oh,
Are there two horizontal tangents? Yeah, there's two horizontal tangents. Where's one of them? Right there. Can you all see where it is? 3, negative 199. Write that down. And in fact, draw a little sketch. One horizontal tangent. Let's make a little sketch of this so we know what our graph looks like. The graph goes like this. And one of them is at the point 3, negative 199. And where's the other one? Negative 7, comma 801. Great. You all have graphing calculators. You could start this problem by just doing that. After all, what does this problem say? The graph of f of x has two horizontal tangents. Yes, it does. One is here, and one is here. What is the negative value of x where the horizontal tangent occurs? What is the positive value of x where the horizontal tangent occurs? So what's the negative value?
-7. What's the positive value? 3. Okay, did we already answer the question?
Yes.
We did. But I used a graph. So let's do the problem the real way. We can do it in less than a couple minutes. So it says the graph of blank has 2 horizontal tangents. What do we know about the horizontal tangents? What is the value of the slope? 0. Exactly right. The slope is 0 at those 2 points. So let's take our function and take the derivative. Because the derivative tells us the slope, right? So what's our slope? Sorry, what's our derivative? Term by term by term, the derivative of 2x cubed?
6x.
6x squared. The derivative of 12x squared? 24x. And the derivative of -126x? And the derivative of 17? 0. Okay, so what do we want to know? We want to know when the slope is equal to 0. So we just take that now and set it equal to 0. This is the official legit way, without a graphing calculator, to find the 2 horizontal tangents. Now, can we factor this? We can take out a 2, can't we? In fact, we can take out a 6. Look at this, what luck. We can take a 6 all the way out. 6 outside of x squared plus 4x minus 21. So we factored out a 6. If you have a problem like this on the test, I'm pretty sure you'll be able to factor it like this. Then what do we do? First of all, what can I do with the 6? Just divide it off and get rid of it? So, and you can factor this. X squared plus 4x minus 21. What multiplies to make 21 that adds to make 4?
7.
Yeah, 3 and 7. So this is x plus 7 and x minus 3. And by the 0 product rule, either x plus 7 is equal to 0 or x minus 3 is equal to 0, which means x is equal to -7 or x is equal to 3. Were those what we got?
Yes.
X is -7 or x is equal to 3. All right, that's a really nice problem because it applies what we know about the derivative function representing slope to say set the slope equal to 0 so that you can actually find the maximum and minimum of a problem. Okay, well, I guess I'm out of time. I mean, hey, do you guys just want to stay for another 30 minutes?
Yeah.
I always make the offer, and so far no one has taken me up on it. Well, as I said, I will post the practice test online, hopefully later today. I'll go work on it right now. And that way you can go through and look at the solutions and come back on Tuesday ready to take your test.